Hello everyone, welcome back to Nexus Olive Tech channel. Today we are going to fully understand the push button in Arduino, not just connected it and copy the code. We will understand what push button actually is, how current flows, why resistors are needed, and what pull-down resistor and pull-up resistors are, and how Arduino built-in pull-up resistor works. By the end of this video, you'll truly understand the push button in embedded system. What's push button? A push button is electrical switch. Its job is simple. When it's pressed, it connects the circuit. When it's released, it disconnects the circuit. The push buttons are called a momentary switch because they only work while we press them. Internal structure. What is the internal structure of the push button? Push button usually has 4 legs inside the push button. The 2 pins on one side are already connected together, and the 2 pins on other sides are also connected. When we press the button, both sides become connected. This allows electricity to flow through the switch. Basic push button circuit components. For this demonstration, we need a push button, LED, 220 ohm resistor, power supply or battery, which is 9 volt. Why we need 220 ohm resistor? The LED needs protection. If we connect an LED directly to the power, too much current can flow and LED can burn out. So we use a resistor to limit the current. A common value is 220 ohm. Correct push button connection. Now let's make the correct connection. Positive supply to the push button to resistor, resistor to LED, LED to ground. When button is pressed, current flows and LED turns on. After making the correct connection of push button, the wrong push button connection. This is the common beginner mistake. If the push button is connected on the same side incorrectly, both pins may already be connected internally. That means LED may stay on all the time, even without pressing the button. Okay, next we are going to step deeper into Arduino input circuit. We are going to explore what pull-down resistor is, what absolutely essential, and what on earth floating input means. Best of all, we will learn exactly how to wire up an external pull-down resistor with your Arduino. Let's get started. Why digital input needs stable state? To understand this, we first need to look at how Arduino reads information. A digital input pin is designed to understand only 2 distinct states, high or low. When the pin senses voltage, it reads as high, and when there is no voltage, it reads it as low. But what happens if the pin isn't connected to anything at all? That's when we run into major problem called floating input. What is floating input? Floating input happens when the pin isn't cleanly tied to the voltage source or to the ground. It is just dangling in the mid-air. Because Arduino digital pins are incredibly sensitive, they act like tiny antennas. They pick up random electrical noise, static electricity from your finger, or even electromagnetic signal from nearby wire. This causes the pin's voltage to fluctuate widely. As a result, Arduino gets confused and randomly reads high, low, even if you are not touching the button at all. Why we need a pull-down resistor? To fix this erratic behavior, we use a tool called pull-down resistor. Think of it as an anchor. When the button is not being pressed, this resistor gently pulls the input pin down to ground. This gives electricity a safe path to flow away from the pin, ensuring rock solid stable flow signal. Why we use 10k ohm? You may wonder, why do we specifically use 10 kilo ohm resistor? Well, it's all about balance. If we use resistor with too little resistance, we would waste a ton of battery power and current whatever the button was not pressed. On the flip side, if the resistor was way too high, the pin would become weak and start picking up random noise again. The 10k ohm resistor is a perfect sweet spot because between circuit stability and low power consumption. Let's put this into practical and build circuits. Don't worry, the wiring is pretty straightforward. First, let's hook up our LED. Connect Arduino pin 13 to 220 ohm resistor. Run that into the long leg of your LED and connect short leg back to ground. Next step is our push button. Connect one side of the button directly to 5 volt pin. On the opposite side of the button, connect the wire going straight to Arduino pin 2. Finally, from that exact same side of the button, insert your 10k ohm resistor and connect it to the ground. That's right, there is your external pull-down resistor. How the pull-down circuit works. Let's trace the path of electric current to see how this works in real time. When the button is released, the 5-volt line is cut off because of our resistor. The pin 2 is safely tied to the ground, means Arduino reads perfectly steady low. The moment you press the button, the 5-volt path opens up because electricity takes the path of least resistor. The 5-volt rushes straight into pin 2, overpowering the 10k resistor. The Arduino immediately reads high and your circuit stays completely stable the entire time. Let's move to the code part. I will put the code in my Telegram channel. We start by defining our variables. We assign our push button to pin 2 and our LED to the pin 30. We also create an integer variable called button state to store readings. Inside the setup function, we initially serial monitor and configure our pin. We set the button pin as input because the Arduino needs to listen to the incoming signal from the button, as an input because the Arduino needs to listen to the incoming signal from the button. Moving into the main loops, Arduino constantly checks the pin 2 using digital read. If the button states read high, the Arduino triggers the LED to turn on. Otherwise, if the button is released, the LED turns off. If we open up the serial monitor, you can see this logic in action. While the button is idle, the screen scrolls with a steady stream of 0. Press the button, it instantly switches to 1. As a beginner, the most critical thing to remember is this: the pull-down resistor doesn't stop your button from working. It keeps the input grounded and quiet, preventing the chaotic guess game of the floating input. Let's move to internal pull-up resistor. What if I told you that Arduino already has this resistor built inside the microcontroller chip? We are going to learn how to activate the Arduino internal pull-up resistor. This allows us to build exact same push button circuit without using single external resistors. Let's dive in. What is the pull-up resistor? The pull-up resistor does the exact same job as a pull-down resistor, but with one major twist where it connects. While the pull-down resistor ties your input to the ground, the pull-up resistor connects input pin up to 5-volt line. The goal is identical. It stops the pin from floating and keeps signal perfectly stable. And here is the best part. Arduino has this pull-up resistor built right into its hardware. You do not need to buy or wire external 10k resistors. We can turn them with just single line of software code. Because we are switching the methods, our wiring changes a bit. In our old pull-down circuit, one side of the push button went to 5-volt and other sides went to pin 2, and we had this external running to the ground. With the internal pull-up resistor, things get beautifully simple. One side of your push button connects to the pin 2 and the other side connects directly to ground. That's it, no external resistor required. As for our LED, the wiring stays exactly the same as before. Arduino pin 13 connected to 220 ohm resistor, which goes to positive leg of LED. The short negative LED goes straight to the ground. How the circuit works and logic comparison. Now let's look at how electricity moves, because this is where a lot of beginners tripped up. When the button is not pressed, the internal pull-up resistor automatically ties the pin 2 to 5-volt inside the Arduino. So when the button is idle, the Arduino reads high. The moment you press the button, the pin 2 gets connected to the ground through the switch. The voltage drops to 0 when the Arduino reads low. If you notice, the logic is completely reversed compared to our last project. With the pull-down resistor, released button means low and pressed button means high. But with our internal pull-up resistor, a released button means high and a pressed button means low. This is one of the most important concepts to remember in Arduino programming. So many real-world Arduino projects rely on input pull-up. It makes your circuit cleaner, reduce the number of components you need, simplify your wiring, and handle the floating input completely in software. Now you officially master both method handling digital inputs. You know how external pull-down resistor and how Arduino internal pull-up resistor can give you exact same stability with zero extra hardware. If this video helped clear mystery of input pull-up, please hit the like button and leave the comment below with your thoughts, and subscribe to Nexus Olive Tech channel. Thank you so much for watching, and I will see you in the next lesson.